everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm up 30 seconds on the screen. Let's get at it, people. 6 minutes, 6 minutos. Make sure you get a conclusion for this one, please. A statement at the end. Copy and go. Let's go. Once again, for this one, I do want a statement at the end with your conclusion. Let's see how that looks. All right, here we go. Start off with mu. What'd you get for mu? M. Let's go with Moses. What'd you get? 9.6. Hands if you got 9.6. That looks about right. We need a standard deviation. Approximately. Check with your neighbor, and Moses is going to pass them one. Standard deviation. All right, good conversation. Pass someone, Moses. Who? 1.43. 4.43. Hands if you got something like that. No? 1.9. Hands if you got something close to 1.9. Yeah, that looks more closer to that. Pick your computation. Bless you, Isaiah. So we should be at 11.5 on positive 1 standard deviation, and negative standard deviation we should be at 7.7. Is my computation correct? No? 7.6? From 9.6? $7.6 plus 1.9, 5, 8. That's 9.5, and we're at 9.6. So, statement. What is your conclusion? Tell your neighbor your conclusion, and then we're going to pass it to, how about Thomas? Thomas is going to enlighten us with a conclusion for that data. So here are the shoe sizes of 5 students. What would be your conclusion, Thomas? All but 2 are in the norm. Which 2? 7 and 13. 10Q. All by 2 students. Let's just make it a little bit more formal. All right, send that in, please. And copy the agenda. Warm-up 37 done. Frequency tables and graphs. Today we're moving on to stem and leaf. And tonight's home play 2 problems only. 2 problems only. Stay locked in so like that you can have plenty of time to at least finish half of it, or at least maybe finish the whole thing before we leave. Once again, warm-up 37 done. Frequency tables and graphs. We're moving to stem and leaf. And tonight's home play 2 problems only. Okay, we good? Code to access the home play, IUJRB. Write that down. IUJRB. Write that down. IUJRB. That's to access the home play. Tell your neighbor the code, please. All right. Good. From there, here's the home plate for tonight. Let's go. Let's go. All right. Get a Cornell note ready, please. I can represent raw data into frequency tables and graphs. I can represent raw data into frequency tables and graphs. Give you a minute to set up. Write the objective at the bottom left. All right, here we go. So, we started with data. So on your screen, let me send you the screen. Write me what is categorical versus quantitative. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Thank you. So categorical cannot be expressed with numbers. Quantitative can. All right. From there, frequency tables. Tell your neighbor one attribute of frequency tables. What is one critical attribute? Type it on the screen. What must a frequency table have? Type it on the critical attributes. Type it in there. Type it in there. What do frequency tables need to have? 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. What do frequency tables need to have, Aaron? Okay, Enrique. Starts with the letter F. Frequency, my goodness, yes. They need to show frequency. From there we went to graphs. We studied these three: histogram, polygons, ogives. From there we went to bar graphs, time series, pie chart, and Pareto. Today we're introducing two more: dot plots, which I have already introduced, and stem and leaf. And we're going to focus on stem and leaf, but I do want to do some practice on dot plots. So on your paper, write example number 5. Example number 5 on your paper. Example 5. And it reads, the ages of football players. The data show the ages of football players of the New England Patriots in 2012. Construct a dot plot for the data and comment on the distribution. So we're going to do this one together so it can go a little bit fast. Well, let me go through this one really quick. Here it goes. Look up. Dot plot. First things first, let's scan through the data. Look up, writing utensils down. Tell your neighbor what would be the least data and the highest data. Talk to your neighbor. What would be the least and what would be the highest? Least and highest. All right, so what would be the least? Lucas, 21. So that means we're going to start from 20. So look up. This is how you set up a dot plot. Since there's nothing below 20, I'm just going to do the wiggles. Start at 20. Then 1, 2, 3, 4, 25. 1, 2, 3, 4, 30. 1, 2, 3, 4, 35. 1, 2, 3, 4, and 40. Okay. So the least 21, the highest was what, everyone? 35? Okay. So this is how you set up your dot plot. You set up your dot plot by starting your number line from the least amount of data. Put the wiggle so that we indicate that there's nothing below that. And then just start crossing out numbers. So here we go. We'll start with the first one, 28. It's right here. 26. 24. 25. 34. 25. 23. Michael Jordan. 26. 29. 25. 24. 27 and 21. 23 and 24. 35 and 22. 30 and 28. 24 and 26. 24, 26. 28, 23. 28, 23. Oh, 23 is right here. 27, 25. 27, 25. 25, 34. 25, 34. 24, 30. 24, 30. 26, 23. 26, 23. 25, 29, 26. 25, 29, 26. 24, 29, 24. 24, 29, 24. 33, 25, 30. 23, 25, 30. 27, 23, 22. 27, 23, and 22. 30, 32, 34. 30, 32, 34. 22, 30, 34. 22, 30, 34. 28, 25, 33. 28, 25, and 33. All right. From 1 to 5, how comfortable are you setting up a dot plot? Where are we at? 5, yeah? How about a conclusion? Look at it. This is a football team in 2012, the ages of the football players of the New England Patriots in 2012. What can you conclude from that graph? Tell your neighbor, what can you conclude from that graph in regards to the ages? Once again, I said don't copy this, right? I was just showing you how to set it up. Conclusion, Isaiah. The majority of the players are what? Are under 30. How about we do between? Are between 24 and 27? And 27. Hands, if you agree with that conclusion? Observation? Yes? All right. So, with that said, copy this table, please. Example 5. For example 5Q, copy that table, and you're going to create a dot plot from that. I'll give you some time. And it reads, while you copy that, one of Mr. Q's students recorded the hours worked per day for the week. I'll repeat that again. One of Mr. Q's students recorded the hours worked per day per week for September. Represent the raw data in a dot plot. Any conclusions from that data? All right. Since this is less numbers than the one I just did, I hope you finish within 7 minutes. 7 minutes. Go. Once again, the context for this problem, it says, one of Mr. Q's students recorded the hours worked per day per week for September. Represent the raw data with a dot plot and write your conclusion. So, show your neighbor your graph and tell them the conclusion. What do you conclude from that data? Most people, it's only one person. One person. All right, let's see. Who gave us a conclusion last time? All right, pass the one, Isaiah. Ezra, by looking at my graph over there, my dot plot, what do you conclude about that person's hours? That is correct. The student usually works 4 hours per day. Thank you. Hands if you agree with that. Yeah, we got it? All right. So, send that in, please. From 1 to 5, we'll come to you with dot plots. Dot plots. Yes, we got it? All right. There it is. Send it in, please. I want to see what you did. All right. Next, example number 5. Copy this one on your paper, please. Only the data. Copy the data, please. And it reads, at an outpatient testing center, the number of cardiograms performed each day for 20 days is shown. Construct a stem and leaf plot for the data. This is going to be pretty fast, pretty easy. Stay focused. Copy the data. 1 minute. No, 2 minutes. Copy the data, please. All right, here we go. First, when you are given data and they ask you to put together a stem and leaf, first thing you do, look up, sketch a line straight down, please. Straight down. Kind of like plants, that's our stem, the stem of the plant. All right, we good? Next, check what's the least amount of data that we have and what's the highest. Tell your neighbor what's the least and what is the highest. All right, Sam, what's the least? 0.2, okay. And the highest? Yeah, the least is 2 and the highest? 57. All right, so look up. The least is 2, the highest is 57, and we go by 1s and 10s. Look up. So I'm going to do the next thing. 0, 1, 2, 3, 4, 5. Write that down, please. And we're going to start creating our leaves. So this is called the stem. The line is called the stem. Now we're going to create our leaves. Here we go. First value is 0, 2. 0, 2. Cross it out from your data. And it's represented like this. 0, 2. Is there any others on the 0 position? No? Okay, let's go to the 10s. We got 14. What else? 13. What else? That's it. So 13 and 14. So we got 3, 4. Next, in the 20s, what do we have? 20. So that's 2, 0. What else? 25 and 23. Any other? No, that's it. So I'm going to go 23 and 25. Next, 30s. What do we have? 32, 32, 33, 32, 32, 31. Let's start with 31. How many 32s? 1, 2, 3, 4. So we do 1, 2, 3, 4. What else do we have? 33. Any other? And 36? How about in the 40s? We got 44, 44, 43. Any other? And 45. So we're going to start with 43. 2 44s. And 145. And last but not least, in the 50s, what do we have? 51, 52, and 57. 51, 52, 57. So these are what we call leaves. Stem and leaf. Stem and leaf. All right? We good? So, by looking at our data, look at it, what would be a conclusion that we can come up with from that data? And then Gio's going to enlighten us. Tell your neighbor, please, look at the data. What can you conclude? And it said, the context is, at an outpatient testing center, the number of cardiograms performed each day for 20 days is shown. Construct a stem and leaf plot for the data. All right, Gio, what would be your conclusion? You need help? All right, let's pass it to Jordan. The average cardiograms performed each day is in the 30s. Hands if you agree with that? Yeah. Notice 31, 32, 32, 32, 32, 33, and 36. So yes, there you go. From 1 to 5, comfortable are you with stem and leaf? Or are we with stem and leaf? All right. Send that in, please. All right, as you're sending that in, let me set this one up, example 6Q. Don't copy this one. This says, an insurance company researcher conducted a survey on a number of car thefts in a large city for a period of 30 days last summer. The raw data are shown. Construct a stem and leaf plot by using classes. Look up, please. In this case, they want us to do a stem and leaf, but they want us to keep them grouped together in different classes. So look up. What would be the smallest class? The smallest class is from what? From 50 to what? 54. So you would start it like this. Look up. 5. And then you're going to scan your data. Look up, please. You're going to miss it. So from 50 to 54, we have 1. Where else? 2. Anything else? 2, 3, 4, 5. Anything else? That's it, right? So I'm going to start with 50, right there, 50. 51, there's 2 of them. 52, there's 1 of them. And 53, there's 2 of them. Am I done with class 1? Yes. So if I go to the next class, from what numbers to what numbers? From 55 to what? 59. So I would do another 5 and look for numbers from 55 to 59. Do the same thing and set up the next class. Does everybody see what I'm doing? All right. So, last one. Look up. There's another one called also stem and leaf, but when they ask us to sketch this back to back when you compare 2 different data, look up. So to set one up like this for Atlanta and Philadelphia, and this one says number of stories in 2 selected samples of tall buildings in Atlanta and Philadelphia is shown. Construct a back-to-back stem and leaf plot and compare the distributions. Look up, please. Look at it. This one starts with the 20s, 30s, 40s, 50s, 60s, and 70s. And then for Philadelphia, we go to the right. For Atlanta, we go to the left, but with the same process. Okay? We good? All right. So, with that said, a couple of more things. Look up. You're going to be looking at different graphs such as these that are misleading. Now, these two graphs are titled Vehicles on the Road. And then it says here 3 different competitors. Look at it. Which graph do you think is misleading? The one on the left or the one on the right? And talk it over to your neighbor. Which one is misleading? The one on the left or the one on the right? All right. Jordan, pass someone. Hades, which one is misleading? The one on the left or the one on the right? The left. That is correct. Now, why is it misleading, Mr. Q? Because the one on the left only goes from 95 all the way to 100, whereas the other one is actually scaled by 20s, and it's more appropriate in the scaling. This one shows that the one on the right is the least on the road by a lot, which is not. It's only what? Only 2 units away. So, here goes another one. Which one of those 2 is misleading? Tell your neighbor. Which one? Hades, pass someone. Aubrey. Which one is misleading? The one on the right. Does everybody see that? That's obvious, the misleading one. Yes, why? Because they're trying to make it look like it's a lot different by the graph that they created. All right, so with that said, home plate for tonight, there it is. Get started, stem and leaves. You guys have exactly 13 minutes to finish. Those of you on following on YouTube, make sure you put some work in. See you guys next time. Peace.